12, you're going to deal with asymptotes quite a bit because they are the no-go zone. They're your non-permissible values is what they are. Okay? Super easy. They're your non-permissible values as a visual on a graph. So we're going to take those, we're going to pluck those non-permissible values from chapter 6 and we are going to vomit them onto a graph and they result in a straight line that is invisible and it becomes a boundary. Like non-permissible values are, they cannot happen. That's where your graph cannot happen. So your asymptotes, these are related, we'll start here since we're talking about it, related to NPVs. Okay, so the graph does not exist. Okay, so what you need to know is they are a dashed line. So when we graph them as a dashed line. The function is going to approach them. You see that? The function will approach, but never, I'll even capitalize that, never touches or crosses. So these are kind of like your no-go zones. They're just straight lines on the graph. They are vertical line. Do you guys know what a vertical line is? Up, down, right? So vertical axis, vertical line. So they're related to our non-permissible values. So let's say our non-permissible values was x cannot equal 2. Let's just say that was your NPV. You figured out your NPV was that. What that would look like on a graph is like 1, 2, 3. I would take my handy dandy ruler and I would put a dashed line where x is equal to 2. So that thing here is an asymptote. And that's because their non-permissible value is 2. That is so not a straight line. And I did it with a ruler. It's the best I got for today. So asymptotes are just our non-permissible values in an image, in a graph. So we're just going to take those and put those there. Okay, let's go back to a reciprocal function. What's the reciprocal of 2?
1 over 2.
1 over 2, 1/2, right? So what did you guys do there?
Flip it.
Just flipped it. So if I give you a function that is f of x equals x plus 2, what's the reciprocal function of that? 1 on the top, the other stuff on the bottom. So in reciprocal functions, we're going to use that f prime. I don't know why I'm not writing in this stuff in the reciprocal box, but we'll just go with it for right now.
F prime's the little apostrophe.
The little apostrophe, yeah. I don't know why I'm doing that, but that's going to go in there. Do what you will with your notes. Oh, no, it's not f prime. That's wrong. It's f negative 1. Oh, it's a good thing we all write with erasable things. Okay, so now the last box I have is an invariant point. So an invariant point, what does to vary mean? Like answers may vary. You get that in the answer key. Change, right? There's all kinds of different. So invariant means no change. So no change. So the point is the same the f of x graph and the reciprocal graph. So it's a point shared by the original graph and the reciprocal graph. What is the only number that you can take the reciprocal of and it has the, well, there's two of them. What numbers can you take the reciprocal of that have the exact same value when they're regular and when they're reciprocated?
0.
Nope, because if I have 0 on top and I flip it to the bottom, what happens there?
Will it just still be 0?
Nope, when you divide by 0, you get the error in your calculator, right? Because dividing by something means like you're breaking it into groups and you can't have 0 groups. 1, that's the first one. Yep.
10.
Nope. It's very similar to 1.
3.
No, because 3 flipped is going to be 1/3.
Square
Square root of -1 is an imaginary number,
Well, if it's an
Just
imaginary
negative.
number.
but you're almost there.
-1.
-1.
Oh, okay.
And so what was the big thing when we were doing absolute values? Our y values couldn't be negative, right?
Yeah.
Could our x's be negative?
Yes.
Right. So when we're talking about the functions, we're really talking about what's happening with the y values. So we're looking for invariant points would be when y is equal to -1 and +1. Because you're going to reciprocate only the y values, not the x. Okay. A reciprocal function is in the form f of x 1 over another function, g of x. Just going to say. What do we know? Where g of x is a polynomial and the domain of the reciprocal function consists of all values of x for which g of x cannot equal 0. All that means is we have to figure out our non-permissible values and we have to state them and we have to graph them to be our boundaries. I don't know if okay, let's do this one. It's already done for you. That's what the graph of 1 over x looks like. But let's back the bus up. Can we do a table of values for this function here? Just a little table of values. I'll give you the x's. -2, -1, 0, 1, 2. Y equals x. So what are my y values for this one?
This exact same.
They're the exact same because y equals x. They have no change. So -2, -1, 0, 1, 2. That's pretty exciting, eh? I know you're excited by that. So if I were to graph them, I would get that line right there. Everybody agree with me? My blue line? So that would be the original function. But if I were to do the reciprocal function, and I were to create a table of values for it, what is the non-permissible value of this function here? 0. X cannot equal 0, right? So the NPV here is x cannot equal 0. So I'm going to go back to this graph, and I'm going to grab a red pen. So I know I'm going to have a vertical asymptote along the y-axis. It's kind of hard to see, sorry. My red isn't very bright. So create it with a dashed line. That's still really not great. Let me see if I can find a better one. Oops, I just took out my blue there for a second.
On the y-axis?
Because x equals 0 is going to result in a vertical line. So I'm going to have an asymptote of It's a little bit better. You can kind of see it. My yellow is going to be my asymptote. Thanks, Johnson.
You come to join.
Perfect. We're recording a lesson.
I'm coming to check your list. Checking your list
Would
twice.
you like any of these children? You can have them all. Except Tyler Wombold, who's out of town. He's missing a super important lesson. I can't pause this. This is my only thing. What's
So
your name?
I want to know your activities for next week.
Okay. I don't know what it's gonna record. It might record this. Can I email it to you, or are you leaving right away? No, you're not leaving
No,
till
I'm
tomorrow.
not leaving till
Can I give it to you
after school.
after school?
Yeah.
Okay. Just because I don't know what this will record, if it will record my screen or not, like my computer screen or not. Okay. Okay. So now if we're going to jump into the table of values, and I'm using the exact same x's. So I'm using the exact same x's. What's happening with y? We're just doing the reciprocal of x. So
1 over negative.
-1/2. Oh, -1. There's that invariant point, right? Because it's shared between the original and the reciprocal. 0, what happens to 0 when the 0 now is in the denominator?
0 over 1.
It'd be 1 over 0,
1 over 1.
right?
Error.
So that's the error. So in math, we call that undefined. What's happening when x is equal to 0? I got an MPV happening there, right? So when it's undefined, that gives us our asymptote. Right, so everything's kind of interlinked. Like when you move that 0 to the bottom, so 1 over 0, like your calculator's going to kick you out an error, but we know that undefined is going to result in the asymptote on the graph. Reciprocal of 1? 1, another invariant point, and then this one will be 1/2. So if we were to graph all these pieces, what do you notice is happening on the right-hand side here? So this would be our 1, 1, 1. Oh, look at that. There's a shared point. And 2.5 is right there. Now, if we were to graph more points, we would see this pattern. Is there any time that these values would become negative? Like if I had 3 here, this would be 1/3. If I had 20 here, 1/20th. If I had 100 there, that'd be 100th. So what's happening to my numbers? Where are they getting closer to? Note what number are they getting closer to? So that's 0.5, that's 0.3 repeating. What's 1/20th?
0.02.
I love you guys. I think it's 0.5. There we go. Okay, so where are we getting closer to? What number are we getting closer to? 0. So we are headed towards a y value of 0. FYI, you have just done a limit of a function, which is grade 12 calc.
We just
So,
did grade 12.
right there, you just did grade 12 calc. So it's still not touching. It's going to get really, 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 really close, but it's never, ever going to get to 0.
Never.
We're never. But the limit of the function is what you're approaching, and that's 0. So welcome to grade 12 calc. That's unit 1, limits of functions. All right, so that same thing is happening on this side as well. We're going to approach these things. So what we haven't talked about, though, is that there is a hidden asymptote. I'm going to pick a different one. There's a non-talked about asymptote that is a horizontal line. So we will actually never touch that x-axis there. And I'll get into a little bit more of that, and we'll dive deeper in it to pre-cal 12, but we won't go too deep in it to it now. We just did calculus. We can't be required to do anything. So because we have an asymptote on the x and the y, we have no x or y intercepts.
I was just gonna say, you just did grade 12 calculus. Everybody should take a break.
I feel like it's done. We just did a little bit of... All right, so this one, the horizontal asymptote, is related to some rules on the next page. The vertical asymptote is related to your non-permissible values. Okay, are we having fun yet?
Yeah.
All right, that is the basic graph. In grade 12, we're gonna do things with x's on top and on bottom, but not in grade 11. We are always gonna have a number 1 on top.
And what's the horizontal asymptote?
Right here, next page. Next page. So when I talk about the rules, this is what I'm talking about, is this next page. This is the list that I give my grade 12s for graphing rational functions. But for us, we aren't going to do all these rules. Okay, if we can, we're going to plot the y-intercept, if it's possible. We're going to sketch any asymptotes by finding your MPVs. Those are your vertical asymptotes. Got it? Now, you have to sketch the horizontal asymptote, if any, by using the following rules. In grade 11, the only rule we have is that the numerator's degree is less than the denominator, because there'll be no x's upstairs, because it always will be a 1, because we're doing a reciprocal function, so it's always going to be a 1 in the numerator. So the numerator's degree is less than the denominator's degree, so y equals 0 is your horizontal asymptote. Grade 12, you're going to have to decide what kind of asymptote you have. And then calculus, they do some funky stuff there, but we don't go too much into that. We do that more in university. Okay, super exciting stuff. Use a table of values to graph a few key points, and then you're just going to connect the points with a smooth curve between and beyond your vertical asymptotes. So that's how we're going to graph it. This is what I give to my grade 12s. This is what I'm giving to you. But all you need to know is your horizontal asymptote for this unit will always be y equals 0. So you're going to have that hidden green asymptote on the x-axis. Okay. Let's graph stuff. Okay, we're going to graph this function and its reciprocal. Lots of people miss that. I want this graph and the reciprocal graph. Let's do a table of, what kind of graph am I going to result in here? What am I going to get when I graph that?
Straight line.
Straight line. Easy peasy, right? Grade 10. So we have a linear okay. Can we do a table of values for this? Okay. Doing a table of values for your original function is going to be super helpful for you. And I like to use those basic 5, and let's substitute them in. -2 is going to give me a -15. -1 is going to give me -12, -9, -6, -3. Those are a lot of negative numbers. How does that make you feel? Okay. What's the pattern here? I think we're adding by 3. So let's go one more on this side just so we can see it. Let's go one more because we can. So I have an x-intercept, I have a y-intercept, life is good, I can go ahead and graph these points. Now you guys are like, I can do this from the equation, why do I need a table of values? One, a table of values will never lead you wrong. Like if you are not sure where to start with the table of values with a function. Like they will help you time and time again. It will also help making the reciprocal function graph a little easier. Everybody good with that? All right. So shall we plot these points? Or shall we look at the table for our reciprocal function?
Reciprocal first.
Okay. So I'm using the exact same x's. They don't change. And then what am I doing to the y's? I'm flipping them all, right? So negative 1/15, negative 1/12, negative 1/9, negative 1/6, negative 1/3. What happens with 0? Undefined, because that becomes 1/0, and that can't happen, so I'm just going to say that it's undefined. I like to simplify things and just use UD. What do we know that that's going to turn into on the graph? An asymptote, and it's going to be your vertical kind. So get back to that. And then 4 is going to be 1/3. Maybe I will leave.
So if an x value is undefined, it'd be a horizontal asymptote?
No. We're never going to flip the x values. So our x values are always going to be our x values. Our horizontal asymptotes are based on those rules, which are based on the degrees of the numerator and the denominator. And because we always have the number 1 on top in grade 11, it's always going to be that x-axis. Okay? All right. So let's graph some stuff. Yay, us. 1, 2, 3, 4, 5. Now, I'm making some life choices here. I'm making them for all of us, so you guys get dragged into this. What do you notice about all my y values? They're really, really, really tiny, right? Like 1/3, 1/6. Like they're really, really tiny. So what I think I'm going to do here is I have a lot of big values, like 15, 12, and stuff like that. I don't think I'm going to end up graphing a lot of those. I think I'm just going to go up by ones because it's going to help me. I'm going to have to make a decision on my increments based on this graph and that graph. So -1, -2, -5. Okay, I've made choices on my increments. You guys are like, you're not even going to see the y-intercept. And I realize that, and that's a sad day, but I want to make sure I can graph these okay. All right, let's graph our original function, so that linear equation. Let's graph that first.
If it was on a question, what would be required? How many points?
You want to have at least, okay. You need to have enough to make the shapes on the left and the right-hand side of the asymptotes. So you want at least 2 on either side of the asymptote. Okay, I'm graphing this one, sorry. 2 is -3. 1 is -6, that's off. And then 4 is +3. Now, I'm sure I've said this before, maybe I haven't. I would, if you don't know what your y-intercept is, don't have your graph cross the y-axis. This one we know it's at -9, but if you're just putting a line on there, especially for a parabola, and you don't have the data that goes over to the y-axis, don't put your arrows across it, because if you cross it the wrong place, that's a half-mark deduction. So for every graph that we do, we're going to put 2 graphs on this coordinate plane. So they each need to be labeled with what they are. And technically, you should have 2 points labeled on every graph. I'm not going to label 2 points because I think it's going to get busy. You know what I mean? Okay, now I'm going to put on my asymptotes. Where is my vertical asymptote, my up-down asymptote? When x is equal to 3. So my up-down asymptote, my vertical asymptote is right here. What's that related to? What point is that on the original graph?
The x-intercept.
The x-intercept. Things are coming together now.
Like the building,
Mm-hmm.
small stuff.
Kinda, yeah. All right, and because of the rules, I have a horizontal asymptote. Along the x-axis, so that's where y equals 0. So please note that they are dashed lines. These are boundaries. Our reciprocal graph, not our inverse graph, our reciprocal graph cannot touch or cross them. They can get really, really, really close, but they can't touch or cross them. Okay, so let's graph some points. You need to have points on the left-hand side of the vertical asymptote and on the right-hand side of the vertical asymptote. How many points do I have on the right-hand side?
1, 4.
So I should probably have another point. So where would 5 be? And if I go back to my tables, 5 over here would be 6. So 5 over here would be 1/6. And again, guys, you are human. You're going to get really, really close to that line. We just don't want you to touch or cross it. Okay, we've got a ton of points on the left-hand side. So I know at 0, I'm at a -1/9. Maybe I don't want to go that much. 3 is undefined. 2 is -1/3. So that's my 1/3. 1 is 1/6. Okay, so what's the rule about asymptotes? Do not cross, do not touch. But you want to get close to them. Okay, so that's the left-hand side. Now the right-hand side only has 2 points, just like this one only had 2 points. You guys don't have time in your life to do like 2.5, 2.75. You don't have that kind of time. It is always this shape. You know what I mean, jelly beans? Like it's always going to be that curved shape. Now we want to cross at -1/9. That's really, really close to that line. I may have been able to get a little bit closer, but again, we are only human. So you've got to practice those smooth curves, and if you've plotted that point, then you need to make sure you go through it. Now, I will say, this is sometimes a confusion, this and this have to both be graphed in order to get the full marks for that graph. The right-hand side and the left-hand side make up the entire graph. You can't just graph this right-hand side and be like, I'm done, I've graphed it. Both these red parts make up the entire graph. They're both part of the function. So if you don't graph, and I've seen students do this before, they get this laid on, they're happy, they get all kinds of points, life's good, and then they don't graph this side. I'm gonna deduct you a lot of marks off for that, not a half mark, okay? Like at least 1 full mark, and if this is a 3-mark question, that's a big chunk of change. Okay, how do we feel about that? No, because there's quadratics next.
Like this and this?
Yeah, Uh-huh. So I guess my question is I'm looking, do we want to, so it's really a 2-question assignment. These ones are all linear, and these ones are all quadratics. So do you want it, like we have tons of time. Do you want to, I have 2 days booked for this. Do you want to stop and work on those 4 graphs, the linear, just work on linear, and then tomorrow we'll come back and do quadratics? Or do you want to see quadratics today?
How long would quadratics take?
It's going to take at least 10 minutes to go through.
We'll finish it.
Okay, I got finish it, do it tomorrow.
Finish.
Okay, I got 2 finishers. I have 2 finishers and 1 bold enough person to say, let's do it tomorrow.
I mean, are we gonna do a full lesson on quadratic?
Nope, you're going to do 1 example, and then you've got 4 graphs to do. Tomorrow is just a work period. Like, so if you finish the lesson today, I'm going to give you, well, I'll probably take the other work period away.
Would you bring the quiz closer?
No, quiz will stay where it is.
Oh, we'll do chapter 8 quickly?
We'll do chapter 8,
And we'd be able to do the test?
maybe. We'll see.
Yeah. Finish.
Okay, let's finish it up. And then we have a full and complete video. Okay, here we go. What do we need to know about quadratics?
Vertex and x-intercepts.
Okay, let's do our vertex. So, what's our vertex? I know what it is by just looking at it. You guys might not feel comfortable with that. This could be written as,
0 and 4.
right? So it's 0 and -4. But if you're not comfortable with that, this would be 0 divided by 2. 0 divided by 2 is 0. Substitute 0 in here, that's a -4. Okay, good job, everybody. All right, I'm going to jump into a table of values right away from here. So when I do my table of values for quadratic, they're very specific. What goes in the middle of my table?
The vertex.
My vertex. And so I'm going to pick some points to the left of it, and I'm going to pick some points to the right of it. Just so happens that it works out to be the same, but this is not always the case with parabolas. So this is your chapter 3, chapter 4 stuff. All right, let's look at this. Let's fill this in. -2 squared minus 4 is 0. We've got -3, -3, and 0. That's exciting stuff. Let's throw in -3 just for funsies and a +3 just for funsies. We got a 5 and we got a 5. All right, how do we feel about that? All right, okay. Can you guys see your asymptotes in the table? Your vertical asymptotes in the table?
Yeah.
Yes. But if you can't see them, we're going to go to the inverse function, which would be 1 over x squared minus 4. What are my non-permissible values for this? What's step 1 when you're doing a chapter 6 question? What's step 1? Factor everything. So what are my NPVs?
X can equal positive and -2.
So if you don't see them in the table, like you didn't find them in the table, you can always solve them out by finding your non-permissible values just like you would if it was a chapter 6 question. So you guys are good at that. Maybe. Maybe. You guys are pretty good at factoring. Not gonna lie. We're getting more comfortable with it. All right, so if we do -3, -2, -1, 0, 1, 2, 3. And don't be afraid to add more stuff to your table if you need to. Like I did a 3 because I knew my graph was going to stop at the x-intercept and I just wanted a little bit more above that. And I'm pretty comfortable with it. So that's going to be undefined. That will be a -1/3. That'll be a -1/4, a -1/3, undefined. Oops. Okay. So again, when I do my increments, this one's a little bit nicer. I'm probably gonna go 1 to 5s everywhere. But I gotta be considerate of both graphs, both the original and the reciprocal. Okay, what do you want to graph first? Parabola or reciprocal of parabola? Parabola. Okay, good choice. 0, -4 is here. And I can plot all those points, but I know my x-intercepts are at -2 and +2, and I have faith that that's going to look good. Let's not make this harder than it needs to be. But some people aren't comfortable with this. If you are not comfortable with it, graph all the points. And then you have more points to go through. So -3 is a +5, so that's way up here. I'm probably not going to graph that. -1 is 3. Oh, look at that. I went through that. +1, look at that, missed it. I got all cocky with my graph. So if adding more points on there makes you feel more confident in graphing, it takes 2 seconds to do it. It is worth it. So please notice that I labeled this one f of x. Because I'm putting more than one graph on the coordinate plane, you have to label each. And I didn't put the equation. You totally can if you want to, but I'm just saying, hey, this is the original function. Okay. Are we good? You guys are still graphing the parabola? Good? Okay. First thing I always do is I lay my asymptotes down first, because those are my boundaries, and it's going to remind me that I can't cross those. So I had asymptotes at -2 and +2, and I also knew that for my non-permissible values. And where is my horizontal one? Where's my horizontal one, everybody? 0. Y = 0. So we're just right on this axis. So your vertical ones will move, but your horizontal will stay where it is until we get to grade 12 and add a new layer to this, and then you'll get more smarts. Do those yellow lines show up okay?
Yeah.
Okay. Okay. A different colored pen just because that helps my brain. You're going to have 3 sections, ladies and gentlemen. You are going to have the left, you are going to have the center, and you are going to have the right. So this graph will contain 3 sections. Not all parabolas will, because this one has 2 x-intercepts. How many x-intercepts can we have in a parabola? 2, 1, and none. Okay, let's graph this stuff. -3 is, I'm going to graph easier ones. I'm going to start with 0 and -1/4. And then I have 1 and -1/3. -1 and -1/3. It's kind of look approximately correct. Okay, so I've just created the inside. I've created the middle section here. So again, it's like a magnet that the function gets pulled towards the the asymptotes, but it just can never touch them. Okay, so that was the center. Now I only have one point on the left-hand side and the right-hand side. I think we can do it okay with that, but it's totally up to you if you want more points. So it's going to be -1/5. If I put a 4 in there, if I want to get another value, it's going to be closer to that x-axis. So really all I'm doing is, again, that magnet is pulling me close, but I can never touch. And then I'm going to head over to this, and I'm going to head up. And the 3, again, I'm at 1/5. And the magnet pulls me close. But again, I can never touch and cross. And that graph is my f to the -1x. So that's my reciprocal graph. I need all 3 parts to get full marks for that reciprocal piece.
For the 3 parts, do we just have to label one of them?
Just one of them, yep.
And that's it.
That's it.
It's not terrible.
It's not terrible, but it's just a lot.